Okay, so we're gonna do the second video. We're gonna do the last question, example 3. So this one says, if a family is chosen at random from the set of all families with exactly 2 children, find the probability that A, the family has 2 boys, if it is known that one child is a boy, and B, the probability that the family has 2 boys if it is known that the first child is a boy. Okay, so basically we're saying, okay, this family has exactly 2 children. So what are our possibilities? Biologically, male or female, 2 children, those are our possible outcomes. So we know we can get 2 boys if we have 2 kids. We can get a boy and a girl. We can get a girl first and then a boy. We can get a girl and then another girl. Okay? So let's do A first. A is asking, what is the probability that the family has 2 boys if we know that one of the children is a boy? Okay, so we know that at least one of the kids is a boy. What is the probability that the other one is also a boy? So we're going to say let A be a family with 2 boys. Let B be a family where we know at least one of them is a boy. So with at least one boy. Okay. So we need to figure out what is the probability that this family has 2 boys given that we know one of them is a boy. So we want to look for the conditional probability of A given B, and that is equal to the probability of A intersect B over the probability of just B. Okay, so what is the probability that A and B happen? Well, A is a family with 2 boys, B is a family with at least 1 boy. So obviously those overlap. There's only one way we have 2 boys and at least 1 boy. So 1 over 4 is our probability for that one. Over the probability of B is that a family has at least 1 boy. That has at least 1 boy, that has at least 1 boy, and that has at least 1 boy. So 3 out of the 4 ways. When we have 2 fractions, we flip and multiply the bottom one, and you're going to get 1 over 3. Okay? Now, that's the conditional probability. We want to know, so if you're wondering how we got certain values there, we can jump here for a second. We figured out the probability of B by doing the probability of B is the number of ways B can occur over just the number of total possible ways in the set. Well, the only way we can have at least 1 boy is 3 possible ways over the 4 possible outcomes. We also know that the probability of both taking place is 1 over 4 because there's only one way we can have 2 boys and at least 1 boy. Okay, so that's how we got those values. Now we can do B. So in other words, there's a 1 in 3 chance that if you know the first child is a boy, if you know that if you know that one of the 2 children is a boy, there's a 1 in 3 chances, 1/3 of a chance is the probability that the other child will also be a boy. So then we'll jump to B. Now B says, what is the probability that the family has 2 boys if it is known that the first child is a boy? So the first born is a boy. What is the probability that the second born will be a boy? That's hard to say. Okay, so let A be a family with 2 boys. and let B be a family where the first child is a boy. So the number of ways that we can have a family with 2 boys is just if we have boy, boy. And the number of ways where the family can have the first child as a boy is if we have boy, boy, or boy, girl. Those are the only 2 ways where the first child is a boy. Okay, so let's look for the probability. Probability that the second child is a boy, given that the first child is a boy. We have our formula here. Okay, so the probability that both can happen is 1 in 4. Okay, there's only one way that the family can have 2 boys and have the first child as a boy. So 1 in 4 over the probability of just B happening, we can see here is 2 in 4, where the first is a boy. When we have fractions, we flip and multiply the denominator, and we get 1 over 2. So there's a 50% chance that if we know that the first child is a boy, that the second child will also be a boy. Okay? Which makes sense because it's a 50-50 chance, boy or girl. So that is how you do that last question. I will leave it straight like that. If you have any questions, feel free to ask me tomorrow, and we can go over a couple of things as well. The main difference is that between this and independent events, independent doesn't rely on anything, so conditional probability doesn't really exist in those scenarios. Okay, I'll see you all tomorrow. Have a great rest of your day.